Welcome to my talk about coordination of serverless functions. Let's simply jump into that. What I want to talk about is basically the problem that you have probably a couple of functions, for example, to book a rental car, to book a flight, or to book a hotel. And now you want to offer a function that books a whole business trip, which invokes the others and actually needs to coordinate them. And that's not that easy to do, actually. There are a couple of ways what you could do in order to get that working. The most obvious is like you could have your rental car Lambda do whatever it needs to do, and at the very end, before it basically finishes, it just invokes the other one and says, "Hey, now invoke the hotel booking form." That's very easy to do. Has a couple of limitations, especially because this might not be available. You have a couple of might run into problems. This is why what I normally see people doing, if they go this way, they use some event bus in the middle, for example, AWS Kinesis or SQS or whatever, in order to do that a bit more robust, right? So you could say like, I booked the car, and then it's booked at publish an event, and this triggers another Lambda to book the hotel. Okay, but this is still a chain. In this case, it's an event chain. The good thing is it's very easy to do. That's why I think a lot of people are really doing it. But the problem is that it's hard to understand the flow that's happening here because there's not one point in the code where you can look at and say, okay, of course, first the car is booked, then the hotel is booked. This is just not visible. You have to look into all the functions. If they are developed by different teams, it actually gets pretty hard. Not only it's hard to understand, it's also hard to change because you probably have to change a couple of functions at the same time. You have to discuss with a couple of people at the same time or whatever. Okay. What's an alternative? The alternative would be to have kind of an orchestration function or a coordinator function, which then invokes the other functions like, okay, I want to book a trip. So first I book the car, and when that's done, I book the hotel. If you do this, you have to basically, you have to solve a couple of problems you get because this is a distributed system. So this is a remote communication. So you should always plan with that other function not being available, not being accessible. So the network could have an hiccup. The function is probably has an outage, is currently redeployed, is planned downtime, whatever it is. So you should really plan for this, definitely. The normal thing, what you do at least, is to do a small retry functionality in order to try it again, for example. You could also have, again, messaging in the middle, which then does the retrying for you. But one super important part of the message here is that if you do this, you have to make sure that your function has an API that allows to check for idempotency. Because if you have retries, you will probably call it twice, right? And this is not easy if you have something like, hey, book a hotel for me for that duration, because you might book the same hotel for the same duration again because somebody, whatever, comes along with you. But you have to create something like a trip ID here already in the trip service and pass it along. Then the hotel service has a chance to see, oh, I already booked that trip. I don't book it again. Super important. Make APIs idempotent, add these kind of IDs. Okay, so if I have that ID, I'm fine. I can do the retries. And even if I have messaging like here or eventing, this has retries built in. So you will normally always hit the retry sooner or later. This is not it. If you're having a remote call, let's assume you have HTTP, you call something via HTTP, you get a network exception, you have no idea what happened. It could be you never reached the service provider. Probably you reached the service provider, it worked for you, then it's exploded, and you have no idea if it committed its transaction. Don't know. Or it did everything successfully and the result got lost in the network. And the thing is, you have no idea which of these three situations just happened. Same thing with messaging. You send out a message, you never get something back. Did it work? You have no idea. And you should really plan for that. You should think about that situation. So for example, if you invoke the hotel, you get an exception, you might have booked the hotel. So you probably want to extend your code in order to cover these kind of situations. And in that example, it could be that you want to clean up, you want to cancel the hotel, right? Or you want to check if the hotel was booked and then cancel it or whatever. You see that this starts to get a bit more complicated than we thought, because we have to add all this logic in the trip booking. So the trip booking orchestration is not as simple as we thought it to be. If I hard code that in a function, I have a couple of weaknesses additionally. So the first and very obvious is if this trip booking function now invokes a couple of other functions, all of them have runtime, you have latency of the network. And of course, if you do that like one after the other, it simply adds up. Like this one has now really takes a long time. So it has slow responses, and it costs you a lot of money because you have to pay for the invocation time on Lambda for compute, even if you're just waiting for I/O. Okay, so that's not a very good design in that sense. The second problem you get is that what I meant earlier on, your other functions don't have 100% uptime. So there are some times when they're not available, and also this adds up because unfortunately they don't agree on the time frame when they're not available. So your availability decreases. And if you not only call 3 functions in a chain, but let's say 10, 20, 30 functions, this very quickly becomes a huge problem. Okay. So one possibility to solve that is to use an orchestration engine, a workflow engine, in order to do that orchestration of the function. And then your trip booking function only kicks off the workflow. Then the workflow engine can do the invocations, the retrying, the cleanup, and these kind of things, because the workflow engine can do that very well. Yeah, and then you basically move a lot of these problems into the workflow engine. That's pretty, from my perspective, pretty good solution. It requires a workflow engine. It requires an additional component. On AWS, it might be step functions. Step functions is exactly what's designed for that. But I'm not a huge fan of step functions for a couple of reasons, which I don't have time to go into today. I probably touch on one later. But if you want to discuss that, just shoot me an email, tweet me. We have a Q&A after the talk, so I'm happy to discuss that. Right. At this point, very important for you to make basically make it transparent. Of course, I'm opinionated like everybody, but my opinionation is that I co-founded Camunda. We're an open source workflow engine vendor, and I contributed to a couple of different workflow engines in the past over the last 15 years, basically. So I'm pretty much enthusiastic about workflow engines. That's one thing. And of course, I'm a bit biased towards the products we do, because I'm quite convinced that we do cool stuff there. It would be really bad if I'm not. But judge yourself. I mean, evaluate yourself. That's the recommendation. Cool. How does it work? I have the workflow engine, and then I can create a workflow model, which basically describes my orchestration. In the easiest case, I could say, hey, first invoke the hotel booking, then invoke the car booking, and then invoke the flight booking. Okay. We will see that in an example in a minute. And then the workflow engine can do the heavy lifting, like do the retrying, do that stateful. So even if that function is not available, the workflow engine could wait there for even days or months if you want to. So probably not our use case, but there are a lot of use cases where it makes sense also to wait for longer times, or probably even wait for response messages or humans or whatever, right? So that's what a workflow engine is great at, waiting for things, and then it's persistent. It can also do one thing, which is quite interesting here. It can also care about consistency. So if you look at the trip booking example, if we book the hotel and the car, and then let's assume the flight can't be booked, we can't roll it back. It's not like a technical asset transaction like we know it from the past in a way, but it's much more than that we have individual functions. They might have transaction management. So the car booking might be all or nothing, right? That's what asset is about, all or nothing. But I can't put them in a joint transaction. It just doesn't work. There are a lot of resources describing that very well. I'm happy to send you a link. But for now, I would take that for granted. I don't have a joint transaction. So that means I have to accept that I have a temporarily inconsistent state. Like I booked the car, then it's booked. I probably even spend money on that, but I don't have a trip yet. I don't have the hotel yet. But if the hotel then fails, what I have to make sure is that I restore consistency, right? In this case, it probably means, hey, the flight couldn't be booked. I undo the other things. Like, hey, I booked the car earlier on, so I cancel it. It's kind of a business undo. I booked the hotel already, I cancel it. I might have to pay a cancellation fee, so it's not really a rollback, but it makes sure I'm consistent again. Right. Good. And that's very often referred to as the saga pattern. You can search for that. So that's what we want to do in the example as well. Let's do that. So what I have here is an example that's also available on GitHub. So if you go to my GitHub account, you will find the trip booking saga serverless example. And there I do exactly that. So I have these functions available deployed as Lambda. So you have all these functions like for booking a car and so on and so forth. And then what I use is Commander Cloud. Commander Cloud is cloud offering for a workflow engine. You can create your own test account right away, create what's called a CB cluster. CB is the workflow engine we use internally here. So that's executing BPMN, the models I showed you. It's cloud native, so that means it runs very well on Kubernetes. It scales horizontally. You can have it as a managed service on Commander Cloud, or it's source available, so you can also run it in your own Kubernetes environment if you're fancying that. Okay, so then I have such a cluster, and I can look into that cluster with a tool called Operate. That's the operation tool where I can see what's currently going on in my engine. And for example, there I have a trip booking orchestration flow deployed. If I want to look at that, that's what I meant. That's BPMN, ISO standard for defining these workflow models. And there, for example, I say, hey, book hotel, that's a Lambda. And I configure that to, for example, call this function name on AWS, my Lambda, and I configure the data which is sent over, and I configure that the result should be stored in a variable. So every workflow has key value pairs stored alongside with it. So the book hotel result, and then I can make, for example, decisions if I go either that path, if the book hotel's result success is true, or the other if that's not the case, for example. And this is how we can model the whole workflow. As you can see, very graphical. In the background, it's always an XML. So if you fancy to write the XML, or if you want to make sure there's no hidden magic, you can always go to the XML file. You can put it in source control and so on and so forth. I deployed that to operate, and then I can run instances of that. How do I run instances? I have a small JavaScript function. Basically, if we go back to the slides briefly, basically that function here, that function just kicks off a new workflow instance. And as you can see, that's very easy. It's Node. It uses the CB Node client, basically connects to the cloud, and then starts a new workflow instance, trip booking, and passes on the data, which is then used in order to be passed on, partly at least, to the other lambdas, and that's it, right? What I can do then next, like I can send, I can use curl, for example, to send over requests to that function. I already prepared that here. And what I have is a small request JSON object I pass along as payload. And I could say, for example, the hotel should not fail, the car should not fail, but the flight should fail, right? So I call that. Or I could say nothing should fail. Let's send that over. Or I could say the car should fail. Send that over. And as soon as I do that, what I see in operate basically is that I have new instances. Probably not all yet, but let's start. So this is right. This is what I currently have. So this one is already started. That was the first one. So for the first one, I said the flight should fail. Yes, so you can see basically the path it took through the whole workflow. That's actually very handy. So you can see you have all the audit data available, what happened here. You have all the data available, what you basically sent over and got back. Yeah, right. And you can see that the others, for example, went a different path. So the second one was the straight line, I think, the happy path. No, right. The happy path, and then whoops, sorry, and then we had the third one, no, this one, where it basically the car was failing. So yeah, you can see that this is actually pretty handy and how a workflow engine works like, and that you have like all the operations tooling around that. What I have in order to get it working very quick additionally, and that's very interesting basically, is that I need one component to connect Command Cloud to AWS, and that's a small what's called ZB Lambda worker here. It's a community extension that's available on GitHub. And what it basically does, it subscribes to the workflow engine, says, hey, whenever you have something for Lambda, like that's kind of a topic name, whenever you have something for Lambda, I can do that, and then it invokes the right function and basically passes on the back the result. The cool thing about that is like this can run in your AWS account, in your security environment, and so on and so forth. If you scroll down here, you find the information how to run it as Docker file, for example, and then it could be in AWS Fargate container or whatever you want it to be. Relatively small, relatively simple to run, and then you have these two connected. Okay, the idea is give it a go yourself. On the README for this example, there's really a walkthrough recorded, which walks you through step by step. So there you can see really how it's working. I don't have the time for that in today's talk. I wanted to dedicate the last 2 or 3 minutes to the question choreography versus orchestration because I find that super interesting and super often discussed. So let's recap. Even that whole scenario where you say, I want to book a trip, and the trip was requested, the hotel was booked, the car was booked, the flight was booked, could be totally event-driven. If there is an error, you have to also make the reverse chain possible. Like, hey, the flight failed, so the car has to undo stuff. The car was canceled, so the hotel needs to be canceled, and so on and so forth. So what you can see is that this is not totally easy. So you have a lot of these kind of event chains going on. And even Martin Fowler wrote quite a while back, not in serverless environments, but the same problem. He said, the danger is very nice. It's easy to make these systems, but without realizing that you're losing sight of a large scale flow and thus set yourself up for trouble in future years. What you can see is like, for example, if you want to change the sequence of things, book the car first. You have to redeploy all the services. You have to talk to all the teams. You have to understand the whole event flows going on. And that's actually pretty hard. And I always use that picture because this is what they sell your choreography. What I see very often, like, hey, no conductor needed. They're just professional dancers. You add somebody, he knows what to do. It will be beautiful. It's not what I see in real life. It's hard to manage, hard to control very often. So if you contrast that with orchestration, you have the trip booking. It commands others like, hey, book the hotel now. That's a function call. Book the car now. Book the flight now. And now if you want to change something, you have everything like in the trip function or orchestration service. Much easier to handle. And this might be beneficial to express actually in a workflow model, even a graphical one. And my favorite example for that is this blog post. It's a great blog post, and Clemens is great. It's not about him, but it's a good example. He describes the same business example, booking a flight, booking a hotel, and so on and so forth. He describes how he implemented the saga. Pretty interesting stuff. But of course, he starts with a picture because otherwise it's hard to follow the code. It's hard to understand what's happening here. So we need the picture first. And this picture, that's documentation. It's dead. It will be outdated the moment you deploy the code to production. And that's the great thing about BPMN. It's readable, it explains everything very well, but it's also living documentation. It's directly executed, it can't be out of date. And you can even leverage that for doing a lot of analysis, for doing operations, and so on and so forth. And that's even very beneficial to something like step functions with for my taste, much too simple visualization, because there are a lot of like complex scenarios out there. Have a look at the time. So recap, function coordination might include orchestration, right? And then you will have something like a workflow engine. Makes a lot of sense. Carefully decide about choreography versus orchestration. It's not either or. You probably need both depending on the use case. So you have to kind of balance that. Not totally easy. Learn to handle eventual consistency. And all these related business problems, not a technical problem, about business transactions, saga pattern, cleaning up correctly, and so on and so forth. And in that respect, idempotency of function is super, super important. Thank you so much. Let's go in the Q&A.